for a review of all of the conic sections. What would help you all remember and understand the content a little better? Just a general overview. Okay. You can do that. Okay, cool. It's a question and answer for Unit 3. Yep. Okay. Wait a minute. Is that what I was going to do today? Hold on a minute. That doesn't sound right. Yes, that is what I was going to do today. But a lot of you have already finished with conic sections. Has anybody, give me a green check if you're done with conic sections. I know Jameson is because you did the portfolio, and that's the end of the project. Austin has. I think when I looked at it, the majority of students had not finished Unit 3, and that's why I decided to do a Q&A. About halfway through Unit 4? Okay. A bunch of people are done with Unit 3. Okay. Okay. I'm thinking. You're at the test now? Okay, you're not taking it now though, right? You're waiting for the Q&A session. A couple people are almost done, right? So, what should I do? What should I do? I'm thinking. Here's what I want to do. Let me do a general overview of conic sections, answer any specific questions, and then if anybody that's working in Unit 4 already has some questions, kind of line those up and I'll try to get those answered as well. And we'll just answer questions about 3 and 4. And I'll kind of split it up. And the questions about Unit 4 will be good for those that are fixing to do Unit 4 because it'll be a good preview of what's to come. Does that sound like a plan? We can kind of address everybody. Oh, there's Earl. All right, super. And if you took the test and didn't do real great, you might need a review anyway. So, and not that I don't know who did and who didn't. I just know that sometimes you don't do good on the test. Okay. All right, super. So let's talk about the different kind of sections, conic sections. And I want to, the easiest thing for me to do is kind of go over the generalities of the formula and what's similar and different and how I remember all the different parts that go along with it. So the easiest one to me is circles. So we'll start with circles. The formula for a circle is x minus h squared plus k squared. No. Y minus k squared. In the question and answer pod, put what that equals. What do you think it equals? Even if it's wrong, you put I don't remember. Everybody real quick, put me something in the Q&A pod. Okay, x minus h squared plus y minus k squared equals, we're talking about circles. All right, a 2 new, yep, that's right. I got a couple people, I'll tell you if you're right. It's okay if you don't remember. Good, Jameson. Got a bunch of people that don't remember. You haven't gotten to circles yet? Okay, that happens. If you haven't gotten to circles yet, you need to pick up the pace. You're close, Amanda. Okay, lots I don't remember. Wow. Okay, so it's been a while. So you need to know this, r squared. R squared. Okay? Okay. Yep, r squared. You just have to remember that. So that's a circle. The HK is the center. And the r is the radius. That's all there is about circles. It's pretty simple. Line of symmetry is all the lines that go through the center because it's a circle. It's got lots of lines of symmetry. Okay, so that's a circle. Easy, easy. Parabola is the next kind of conic section. I think it is the next easiest one because it's the only one that only has one variable or the other squared. Oh, good. I'm glad that helped. Okay, so since that's the case, let's let Alec in. Since it's the only one with a square, it makes it, for me, remember, easier to pick out. Okay, you got two different formulas. You got the parabola that goes up or down, right? And you've got the parabola that goes left or right? Does anybody remember how we remember which one's which? How do we remember which way it opens in the equation? Everybody's like, you don't remember. How do you tell which way a parabola opens? Nope. You're thinking about ellipses. So hang in there with that. And that's what makes this hard, putting it all together. Right. There's all these little things to keep in mind. For a parabola, it's which variable is squared. So the key to this is which variable is squared. You might want to write that down. Which variable is squared? Okay. Yep. Which variable is squared? Right. The up and down one has the x squared, the one that like you're used to seeing. So you got x minus h, and then you got your plus k. We'll let Ashley in. Oh, hey Ashley, good to see you. We just got started a few minutes ago. You might want to watch the recording just to grab the announcements at the beginning of the session. But I got you as here. Okay. And then we've got 1 over 4p, and then that equals y. So that's the equation if it opens up or down. And then if it opens left or right, we have x equals 1 over 4p, y minus k. And that's the tricky part to me, plus h. The y and the k always go together. The x and the h always go together. Okay, so this one goes left and right because the y is the squared term. This one goes up and down because the x is the squared term. All right, you got to focus. That is the distance of the vertex to the, focus is the distance from the vertex to the, well, to the distance of the center to the, oh, I don't know what I was trying to write there. Hold on. I don't know. I'm thinking about something else, I think. I don't know. That doesn't make any sense. The 4p, the p gives you the, which way it gives you the vertical stretch or shrink. This whole number here. And the p, oh, that's what it is. The p is, thank you. The p is the distance from the vertex to the focus, or from the vertex to the directrix. This is vertex. It's just very messy. Let me rewrite that. So p is the distance from the vertex to the focus, and is also the distance from the vertex to the directrix. Okay? So that's what the p, but it's not 4p. P is the distance. So if you have your parabola that goes sideways like this, and this is your vertex, your focus is here, this distance is p. And then you have your directrix out here, well, let's call it out here. That distance is also p. Because sometimes they give you directrix, sometimes they give you the focus, and you need to know how to find all the parts and pieces. Okay? What's the vertex? Type in the chat pod, what's the vertex? What's the ordered pair of the vertex for a parabola? Letters. In the chat pod, everybody real quick. Or the Q&A pod, I'm sorry. Yep, that's right, Jameson. Everybody's trying to write and type, and there you go. All right, very good, Amanda. Very good at Tunu. Yep, that's right, Ambrose. Yep, Ashley. Ashley's like, I'm not sure. I don't remember. It's okay if you don't remember. And you might not have gotten here yet. Some people haven't gotten here yet. I haven't given you a specific. There's no ordered pair, but with this, it's okay. It's okay if you don't remember. A couple people, and if you don't remember, I want you to put in the Q&A pod, I don't remember, because that tells me that you're paying attention. You just don't remember, and that's okay, because I'm going to use this Q&A pod to know who's paying attention and who needs to watch the recording. Okay, so the vertex is the HK. Okay, it's the H, the K, or here it's the H, the K. Be careful with these. A lot of students will confuse that and call it KH. It's not. H is always first, is what is the vertex. Yeah, and I kind of told you that already, so you got to pay attention. Okay, that's okay. And not everybody's here just yet, and that's all right. So your vertex, and that's the good thing with these conic sections, the vertex in the center are always going to be HK. It doesn't matter which one you're working with, it's going to be HK. All right, yeah, ready for ellipses and hyperbolas? I'm going to do those on a different screen because this one's kind of full. Give me a green check when you're, hold on a minute, let me clear out everybody's green checks. Clear. All right, when you are done with this and you're ready for the next one, give me a green check. That way I'm not going to cut anybody off real quick. All right, we'll do hyperbolas and ellipses. Give you the general overview. All right, waiting on Alec and Ambrose. Donovan, did you have a question? Just hit the question, the raise your hand thing. All right, waiting on Alec. Okay, that's no problem. Alec, you ready? All right. So let's do hyperbolas and ellipse. Easy for me to say. Ellipses. Yeah, Alex gone. He'll be back. His computer was probably froze up. That happened earlier today. I kept saying, "Are you there? Are you there?" And I kicked him out. And then he came back and he said how to reboot his computer. So that might have been happening there too. Okay. Ashley, do you want me to do the recording? If you just to grab the announcements at the beginning. Ashley, you just came in just a few minutes late. So you don't have to watch the whole recording. Just stay. Yeah. Just for that little bit. Okay. Cool. All right. So let's do hyperbolas. No, let's do ellipses first. All right. Ellipses. Ellipses. The thing that you have to remember about ellipses is which denominator is bigger. That's the key here. So you're looking for the bigger denominator tells you which way it works. If the x has the bigger denominator, then it opens long like that, if x has the bigger denominator over the bigger number. If it's y over the bigger denominator, it opens like that. So that's kind of in your head. That's a very simplification, but that's how I remember which way it goes. Is whichever denominator is bigger, that tells you which way that ellipse opens. So your general form of an ellipse is x minus h squared plus y minus k squared over a squared, b squared. Don't forget the equals 1. That's very important. You got to have the equals 1. Now this ellipse, a is always bigger, so this ellipse is the one that opens this way. All right, let me clear out all this kind of silliness over here, and then we'll write the other one. And the other one is x minus h squared. It looks exactly the same, plus y minus k squared equals 1. And here, the a is there. Okay, see, the a is bigger, and it's under the y, so this is the ellipse that goes up and down this way. Does that make sense? Oh, no, you don't have to do the recording assignment, Ashley. No, just watch the recording to grab the announcements. You're good. Okay. All right. So now, the important things about ellipses. The focus point is the distance from the center. C is the distance from the center to the focus point. Got to remember that. And your Pythagorean relationship is a squared minus b squared equals c squared. So anytime you're dealing with the focus, or you don't know a or you don't know b, you're going to use your Pythagorean identity. Bigger denominator squared minus little denominator squared equals c squared. C is the distance from the center to the focus. Okay, and what's the center? What's the letters that represent the center? As in all conic sections? There you go. Everybody's typing fast. Oh, that's right. HK. That's right. Type that in the chat, in the Q&A pod. Yep, just type that in the chat, Q&A pod. So the center of a circle is HK. The vertex of a parabola is HK. The center of an ellipse is HK. Guess what the center of a hyperbola is? HK. HK is the center, and the only one that's not called the center is the parabola, and some books even call it the center of the parabola, but that doesn't make sense. It's a vertex. Okay, yeah, HK, 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 HK. If you ever wonder, it's HK. I know it was, some people did both. It's okay. Just want to put it in the Q&A pod because I'm going to export that, and then I'm going to kind of look over it and make sure that you responded. So make sure you responded in the Q&A pod. Okay, cool. All right, so there's our little kind of down and dirty, the bare basics of ellipses. And now let's do hyperbolas. Hyperbolas are almost exactly the same, except for it's which variable is first. Tells you so much about it. If the x variable is first, it opens like this. If x is first, if y is first, it opens like this. Okay, it's not about which denominator is bigger. It's about which variable is first. So let's write the first one. So we got x minus h squared. Hyperbolas are a subtraction. Y minus k squared equals 1. And then your first one is always a, and then your second one is always b. All right, so this one is x is first, so the hyperbola opens this way because x is first. And the other one is y minus k. Now notice k and y always go together. And it's still minus. X and h always go together. It equals 1. And it still has an a squared and a b squared. This is the one that opens up and down, as the y is first. Okay? Now we got to get all the pieces and parts. I don't know if I'm going to be able to fit it on here. Ooh, I don't think I'm going to be able to. Okay, so guess what C is? C is the distance from the center to the focus. So this little nugget of information right here is true for ellipses, and it's also true for hyperbolas. C is the distance of the center to the focus, and that's true for both. The difference is the Pythagorean relationship for hyperbolas is not the same. It is, oh, let me grab my different color, a squared plus b squared equals c squared. And what's the center? Y'all don't have to type this because I know you know, is HK, where your center is HK. So that's the basic bare bones, down and dirty on hyperbolas. Yep, absolutely. About the center, what did I say? I don't even know what I said, Sarah. The C. C is the distance from the center to the focus, no matter if you're dealing with ellipses or hyperbolas. C is always the distance from the center to the focus. Yes, and it's all about the signs, Ashley. That's right. The ellipse is a plus here and here, but the Pythagorean relationship is a minus. Hyperbolas are a minus here and here, but the Pythagorean relationship is a plus. That is the only difference. And in ellipses, the bigger denominator tells you which way it opens, and in hyperbolas, the variable that is first tells you which way it opens. Okay, so this tells you which way it opens on ellipses. So they're very similar, very similar. And it's easy to get it confused because you've got so much stuff that you're looking at that's really close. Now, when you just did the ellipse section, they were all ellipses. It's not hard to get it confused because you're only doing ellipses. The open part. Which way it opens? Sure. With hyperbolas, when the y is listed first, it opens up and down, always, because it's y is first. If the x is first, it opens left and right. With ellipses, the bigger denominator, oh, I did that wrong. I didn't mean to circle this down here. That's not it. A is bigger, not B. Sorry. That. Fix that, fix that. This is what's bigger. In ellipses, the bigger denominator is under the x, so we know it opens, it's a ellipse this way, and the A is bigger, so this one opens this way. Oh, there's Kayla. Hey, Kayla. I'm glad you got to come. I want you to watch the recording for the first part of the session, okay? I'm glad that you're here, but we're about halfway through. Oh, wait, you were here earlier. Was that Camille that just came in? Did you get kicked out? Or was that somebody else? Oh, no, I can't remember. Oh, you have it? Okay. Well, okay. Well, watch the recording of the first part then. I wrote that you were here. How weird is that? I wonder who I didn't write was here. Oh, I just missed you. All right, Kayla who came in, not Camille. Sorry, sorry, two different people, totally different people. Yes, Kayla Cabrera, not Camille. When Camille, I'm not even going to try to say your last name. I don't know how to say that. All right, sorry. So Kayla, watch the first part of the recording. It would be so much better if I saw y'all's faces. I think I want all the students to have a webcam so I can like watch you and I know when you're ready and you look up or you look confused, whatever. It's very good. Austin, you'll need to watch the end of the recording if you have to leave, so just let me know when you go. Or did he already go? Austin, where are you at on that list? Oh, he's already gone. Yeah. All right, hold on, let me write that. Yep. Austin only stayed half the time. He will need to watch the recording. Okay, awesome. All right, so that's kind of the down and dirty on conic sections. Now, those of you who already started Unit 4, any questions or issues that you're having that you need me to address? And the Unit 4 stuff is statistics. You've probably done some statistics before. It's probability and conditional stuff. It's not too complicated. If you have questions, I want to answer those. And then we'll hit back to conic sections and maybe do a couple problems together of conic sections. But I don't want to ignore those of you that have moved on to Unit 4. You're okay? Okay. And I know those first lessons aren't that complicated. But I also don't want you to feel like I ignored the fact that you're working on Unit 4. Yeah, that was really disgusting. Sorry. I should have like muted my mic or something. But every time I do that, it freezes. So you're okay? All right. So nobody with the student statistics. I don't get how you can use, where did that question go? I don't get how you can use multiplication to add. Ah, Tanner. I shouldn't have said that because I love that question. Are you talking about with the probability? Okay, cool. All right. So I try when you type a question in the Q&A pod not to say your name because some people feel really shy about that. And, you know, I try to be respectful of that, but I forget sometimes because I'm not shy. And, oh, Austin's back. Hey, Austin, glad you're back. Okay, so let's talk about that question about statistics because everybody's going to get there. And if something else pops in your head, we'll do statistics for about 15 minutes or so, and then we'll hit the conic sections a little bit more. We're just going to kind of go back and forth. There is here's the thing. When you enter to probability land, life as you know it as a math student adjusts a little bit. And you're like, okay, why? And here's why. Because in probability, if you're doing the probability of an event and another event, and means to multiply. Only in probability. If you're doing the probability of an event or another event, or in probability world means to add. And if you can remember that, it will help you through that whole probability unit, or anytime you have questions about probability. Probability of something and something else is to multiply. I know it seems kind of weird, but it's just the way it works out. And all your life, when you were learning to read, they told and means to add, except when you're working with probabilities. And then it's and means to multiply. I know that seems kind of weird, but it is. And that's only when you're in probability land. And I have to be honest, probability land is not my favorite place to live. So I'm like, why do they want you? And I know why. All right. Where did my little thing go? Okay, so that's not the reason behind it, but that's what you need to remember. Okay, so if you're doing, let's say you have a probability of rolling a 2 on a 6-sided die, and you have the probability of spinning an even on an 8-piece spinner. All right. What's the probability of doing the first event, which is this event, event A and event B, and event B? So what we're going to do is that's going to be the probability of event A times the probability of event B. Right. So the probability of rolling a 2 is 1/6 because there's 6 sides on a die. And the probability of spinning an even number on an 8-piece spinner, well, if it's, let's assume that y'all understood that the spinner looked like 1, 2, 3, 4, 5, 6, 7, 8, like that. There's 4 evens, 4 odds, so it's a half. And then you just multiply. So the probability of doing both is a 12th. Right. Yeah, I know. And everybody that's still finishing Unit 3 is like, oh, I can't wait to do probability. Yep. Yep. Okay, right. So I had to draw my spinner. So that's what my spinner. Oh, Austin's having issues staying in the room. There we go. Hey, Austin, I think you keep getting kicked out. But if I was trying to do the probability of A or B, what that tells me is to do the probability of A time add the probability of B. See, it's really hard to not add. Exactly. So this is 1/6 plus 1/2, and that would give you the answer of the or. It's not hard, but man, I'm telling you what, to remember to multiply when it says to add and, it's like retraining all the math things that you've ever been told before ever. And means to multiply in probability world. I can tell you why, but you probably won't care. But that's the nugget of it that you have to remember. If you're doing the probability of 2 events and it says and, you do the probability of the first event times the probability of the second event. Were they giving you any conditional or what's it? Not conditional probability. The ones that are dependent and they overlap. You did have some of those? Okay. All right, cool. All right, that's good. That's good. They should have them. All right, so does that kind of help know how to handle those with the and the or? And I just guessed that that's what they were asking. So I kind of went down the tangent. It was? Okay, good, good. Now there's another question. If there was a problem that said evaluate the expression, how do you know if it's a permutation or combination? It wouldn't matter because you would just evaluate it with the factorials. Yeah, you would just evaluate. That's a calculator task. Okay, so yeah, if you're just asked to evaluate, it doesn't matter if it's a combination or permutation. You just want to calculate it. Okay, I kind of like probability because after what we're doing with conic sections, it's kind of detailed. Probability is a little lighter, but for some reason, sometimes students don't do too great with probability. But you've done, has everybody done, has anybody not, give me a red X if you've never done probability problems. You have no idea what probability is. Has anybody got a red X? Yeah, see, y'all have done that before. Oh, Morgan hasn't done probability. Okay. And it's not that hard. It's just most of the time you've had some probability at some point in your math skills. Oh, Ambrose hasn't either. Okay. Yeah. You have, but you don't like it. Well, that's fair. That's a fair assessment, and I totally get that. And you don't, it's, yeah. Okay, good. Yeah, and that's one of those things. That's a good point, Sarah, that sometimes when you don't understand something, it's like, oh, this seems so frustrating. But then when you get it, you're like, oh, it's not too bad. So, yeah. Well, and oh, did I not? I didn't do something I wanted to do. All right, we'll do this. We'll do it at the end, and we'll talk about. Remind me to talk about study groups at the end. We'll get done, and we'll talk about study groups. Okay, because I want to, because this and what reminded me is I got some students like, oh, I love that. I didn't like this. We all are good at different and sundry things, and study groups are really important or useful if we can work it out. And I want to tell you what I'm thinking about with it, and we'll see if anybody's interested in doing study groups. So, okay. So does that answer the probability? Does that help you working in Unit 4 to feel like you can move forward with that? Do we need to answer any other probability questions? And did I answer the ones that were asked clearly enough? Because I didn't look and see what the problems were in the book. Everybody okay? Can we do one more conic section problem? Or one more topic-y kind of thing that I think is important? And that'll help those that are finishing Unit 3, and it will help anybody that's going to do the remediation for Unit 3, which I don't have posted yet, but I will. Okay. Internet. Somebody's having internet issues. Okay. That's fine. Donovan, and if you end up getting kicked out and you can't get back in from your internet stuff, just watch the end of the recording. It'll be good. All right. The other thing that I think is really important is to be able to look at a conic section and know what kind of conic section it is. Because if you don't know what kind of conic section it is, then you don't know how to do the graph. Yeah, Kayla, you just need to watch the beginning until when you got here. You were here about halfway through, right? Didn't you just come in about like 1:30, 2:30, whatever time? And then just let me know as long as I watch the beginning of the recording. That's fine. Because I know you're taking notes. I know you're paying attention. That's awesome. Because if you weren't, I'd kick you out. Because I've been doing that some today. Okay. Oh, 2:05. Oh, your computer was freezing up, right? Yep. Okay. So let's talk about the other thing that, because when you go to do the assessment or when you're just doing it, it'll say graph the conic section, give the vertices the center of the blah, blah, blah. And it doesn't tell you what it is. And I think it's important to be able to just look at it and know what it is. So I'm going to make one up and I'm going to see if we can remember, figure out what it is. All right. What kind of conic section do you think this is? Put it in the chat pod, or we won't put this in the Q&A. Put it in the chat pod. What do you think it is? Kind of process what you're looking at. And I made this one up. We don't have to do any work to know. Oh, that's fair. Nope, Giovanni, that's not it. Let's see. Let's see, a trinomial. It is a trinomial, but that doesn't tell us what kind of conic section it is. Jameson, that's good. Good, Ambrose, there you go. A smiley face. All right, this one is going to be a parabola. And let me tell you all the things I know just in the form it's at. I know it's a parabola because the y is the only variable that is squared. Okay, there's no other x, there's no x squared, so I know it's a parabola. There's only one kind of conic section that only has one or the other variable squared, and that's a parabola. So that's one thing I know. I know it's a parabola. I know if the y is squared, that it opens this way or this way, right? And since the coefficient of the y is negative, I know that my parabola is going to open this direction. So I know a lot just by looking at it. And then if I had to complete the square, if I had to do stuff with it, I have an idea of what it kind of looks like. I can sketch my graph and I can get all my pieces and parts. The way the book wants you to do is they want you to get all the pieces and parts, sketch the graph. They do it backwards. I think it's easier to know what the graph looks like so that I can get the pieces and parts off of the graph. Okay. Well, let me tell you another one. What if we had something like that? So if the y is squared, it's left and right. That's correct, Ashley. And there's no x squared, right? Now this one I'm looking at, there's two, the y squared and the x squared is squared. The y and the x have a squared term, so I know it's not a parabola. And the coefficients of them are exactly the same. So I know it's a circle. Yep, that's right, Amanda. Good. It's a circle. I would have to do a little work to get the radius in the center, but if I only wanted to figure out what it was, all I got to do is look at the x squared and the y squared. If the coefficients are the same coefficient, then I know it's a circle. That's pretty easy to do. All you got to do is look at it. Right? Only if they're exactly the same. Exactly the same. Now let's do another one. What if I had that? All right, so I know it's not a parabola because I've got an x squared and a y squared. I know it's not a circle because my coefficients aren't exactly the same. One is a positive and one is a negative. What do I know it is? Close. Close. Oh, sorry guys. It is. It's a hyperbola because the signs are different. So this one's a hyperbola. So when the signs are different, the hyperbola. Because that's where you get your, remember the x minus h squared minus, that's where that minus comes from. Those coefficients are different. That's okay. Okay, and that's, to me, if you can get all these little parts and pieces down, that's what makes this hard. It's not that any of it's really that complicated. And then the other one is ellipses. What do the coefficients of ellipses have to be? They have to be the same sign, but not the same number. Right? Any bigger, it doesn't matter. They just can't be the same. Right, that's one. Then we know it's an ellipse. Okay, so the same sign, not the same number, is an ellipse. Completely the same as, and then so, y'all have gotten my emails, you know, sometimes I read back over them and go, oh my gosh, that spelling is so bad. Like I really have to remember to do my spell check. Section and give all the pieces and parts. Y'all want, let's do one where we're going to find all the pieces and parts. Let me find one. I don't want to, oh wait, I grabbed the wrong book. Let me get the book. Will be good. Let me find the conic section. Excuse me. I put something in the crock pot for dinner. It smells so good. My stomach. Well, maybe. And the hardest section of this chapter is lesson 6, because that's where they start. I'll do that one. Let's do. Yeah, let's do that one. 16. Okay. Plus 6x. And I had to look in the book because sometimes when I make them up, they get really ugly to work. So first thing is, what kind of conic section is it? And they don't tell you. They just say, if it's a this, give all these parts. If it's a this, then give all those parts. What is it? Tiffany is correct. Jameson, good. Gabriel, good. Oh, wait, Gabriel, no, that's not it. Morgan, yes. Take your question mark off. You're right. Atunu, nope. Try again. All right, Javante, good. Atunu, that's it. Ambrose, good. Amani, close. Not quite. Keep thinking about it. What kind of conic section is this? Try again. Uh-oh, where did my graph go? Or where did my thing go? There. That was good. That's it, Amanda. Yes. Okay, so exactly. For those of you who got ellipse, it's not always the second one. And I know some of y'all looked at this one and this one. It's this one and it's the square terms. Circle. There is an x squared and a y squared. It's not a parabola. And the signs are the same, so it's not a hyperbola. So this is an ellipse. Elllip, E-L-L-I-P, an ellipse. I did two P's instead of two L's. Wow, that's really sad. All right, now we've got to get it in the format that we know that the ellipse needs to be in. It's going to be equal to 1. The x's together. And we're going to leave a little space because we need that space. And we're going to put the y's together. We're going to leave a little space, and we have our minus 3. Middle term, we're going to half it, and we're going to square it. So negative 6 halved is negative 3. Negative 3 squared is 9. So I'm going to square so that this could be written as y minus 3 squared. It's a difference of 2 square. I mean, it's a perfect square trinomial where negative because remember we have to have a 1 here. Oh no, we don't have a 1. We have to factor that guy out so that we do. y minus 3 squared. Okay? Now we can find our number that we need here. So we're going to take be careful. Don't do plus 1 and then just add 1 over here, because we added this 1 inside these parentheses. There you go. We added 3 times 1, because this 3 is distributed. If we multiply it, does that make sense? So that just equals minus 3. And then we've got plus y minus this part squared equals 9. Now, is this an ellipse form? Right, there's no denominators down here, so we need to have some kind of denominators. And what else? I'll give you a hint. Yeah. Denominators, we're going to divide each term by 9. That's right. That's right. So we end up with x plus 1 over 9, y minus 3 over 9 equals 1. So which, oh, this is, I'm thinking, hold on. Did I do something wrong? Hold on. 9. Something's off and I can't put my finger on what. Hold on. Did I write the problem down right? 3x, 16. It's kind of left him flying off a la-la land. We're not ready to graph just yet. We got to deal with that. In our vertex form, right, it was looking like a circle to me too. Because that 3 that we factored out reduces this fraction. So 3 goes into 3 once, and 3 goes into 9 3 times. These denominators are never the same for ellipses. Otherwise, it's a circle, not an ellipse. Yeah. Whew. I was starting to kind of sweat that for just a second. Okay. Did that make sense? Now I can breathe again. Okay, fabulous. It is an ellipse. Woohoo! Now we're in our standard form that we can sketch the graph. We've got our 1 over here. We've got our coefficients over here, our denominators over here. That Miss Long found the error of her ways. Let's graph this guy. All right. Which denominator is bigger? The x or so this has a denominator that's bigger here. So I know this goes up and down. at -1, 3, right there. Graph paper would be your friend for this. Then this one, vertice, and we're going to go down 3 units, and there's the other vertice. So that's a vertice, and that's a vertice. And then we're going to go left and right. Go out the square root of 3 this way, and I'm going to go out the square root of 3 this way. So it's 1 point, excuse me, co-vertice. But you see how I just went this many square root of 3, this direction square root of 3, and then I'm going to connect my dots. And there's my really mal-shaped ellipse. Our foci are going to be on this axis. It's going to be here and here, and we're going to use our Pythagorean identity, a squared minus b squared equals c squared, to find the foci. So we would go up the square root of 6, and we would go down the square root of 6, and that will give us our foci. So our foci would be -1, and then requirement up here real quick, and then I'll put that back. So here's a recording requirement. Next week, we're going to talk about 4.1 through 4.4. We did that just a smidge today. We'll do some extra practice problems, and I'll actually pull some stuff out of the book. Study groups. Yes, study groups. If you breakout rooms open, and I put 3 or 4 people in a breakout room working practice problems together. And I was thinking and if you're interested in doing that, I'm gonna keep it small. More than one brain helps. If you're working with 2 or 3 people, you might remember one piece, or somebody else might remember something. I would still be available, but if I have a Thursday morning kind of time to do that. And this is the part that I didn't get to that I wanted to talk to y'all about, was things that I can do better to help you be more successful versus things that you can do that you might not know about. And I've had people kind of all on this list, or you think of anything on this list that would be helpful to your peers or helpful to me. Let me give you the option that you can write on it. Things on the right, on the left, in the blue section that I can do to help you more successfully. And the things on the purple are things that you can do that either you're not doing or that you have found were really helpful, or something that you've done that and I don't know who's typing what, so feel free to be honest. Yeah, give a study guide. Somebody else said that. I have some educational philosophy with study guides that I have a little issue with, and I'll have to put it on both. So the blue side's for me, and the purple side's for students. What could you do to be a better student, or what have you done that's helped you make improvement, or what would you like to see? Yeah, yeah. You know, that works. And so it's I got your error study guides. I've had a couple people say that they would like study guides. I have issues for that. We do live lessons before the unit test typically. Those are the question and answer overlapping. Okay. The practice problems, definitely doing that. Categorize your formulas. That's a really good tool. Good. And once you've kind of looked over this, if you've added what you know, you're welcome to go ahead private tutoring. I do private tutoring on kind of an individual basis, and when you ask me questions, I kind of set that up individually. So make sure that your academy is one that somebody this morning put in there. Mhm. Have a Coke. That's a great. Very good. All right. And I just want you guys to know that I am open to ideas and doing things differently. I'm really going to think about the study guide thing. I've had some issues with that just academically. I have some philosophical. Yeah, I don't want to get on that soapbox. So, but I'm going to think about it any day but Thursday morning. Okay, that's so great. And maybe I'll do it more than once. Maybe I'll potato chips. Ah, oh, it's still my heart. That would make me so happy. Yeah, I know. I know. And I'll get into my academically study guides. I think make students be a little bit lazy, and I not that y'all are lazy for. I'll work on processing that in my head. If I had ninth grade students, I would probably do a study guide. But I just, you know, y'all are 11th grade, 12th graders, some of you. You need to get used to making your own study guide. Everybody does study guides, and I'm like, not me. But yeah, I want to be what's helpful for y'all. So I'm kind of like maybe a fill in the blank study. I don't know. I'll process that. You hate. I got my pre-calc kids loading in at the door, so I will talk to you guys soon. Yes, Kayla. Let's see. I got a question. Kayla, do I have you here? Hold on. Let me see what I wrote down. Just a second. I don't remember when you came in. Hold on. Kayla. I wrote that you came for half of it. So what I need you to do is watch the beginning, and then just shoot me when I'm as long. I got the beginning of the session, and just whenever all right. See you later. Oh, did turn off the